Now this illustration deals with the rod, pipe, and pipe electrodes, or plate electrodes, excuse me, in accordance with NEC 250.52A5 and A7. Now, notice it wouldn't make any difference if it's a plate electrode, a driven rod. It still would only be a number 6 grounding electrode conductor per 250.66A. We know either one of them, rods, pipes, pipe electrodes, plate electrodes, whatever you may have. But now notice if we focus in on the plate electrode, it shall be buried at least 30 inches below the Earth's surface. A 1/4 inch steel or 1/16 inch brass, bronze, or copper could be used in accordance with 250.52A7. But we have certain thickness dimensions that we'd have to have there and a certain size plate. But we found all that information in 250.52A7. And then notice we refer you to a figure loop for information. Figures 16-71, 74, 76, and 78 of Chapter 16 will enlighten you with a lot more information. The grounded conductor has to be at least a number 2 in accordance with Table 250.102C1 because we're consistently using 4-aught conductors. Now, everything you see on that panel board would have to be at least number 2, except for the grounding electrode conductor, which would connect to a driven rod, a plate, or a pipe, and it would be number 6. So kind of keep that in mind. Everything would be number 2 in that panel board for grounding and bonding if the grounding electrode conductor connected to structural steel or a metal water pipe in accordance with 250.66 and A, B, and C. Now, I like this little grounding loop that we have. Notice the grounded neutral conductor at the service is routed with the phase conductors to the overcurrent device in the panel board, and we're grounding in accordance with 250.24C1, C as in car. 220.61C, informational note 2, we could size the neutral at 100% of the load, or we could take continuous load at 125%, add it to 100% of the non-continuous load, or with demand factors. It's an engineering preference there if they're designing the system. And then notice 310.15E3, we use E3 to determine if the neutral in the system under certain conditions is current carrying. And basically, it's a major portion of the load of the neutral is harmonically or non-linear loaded, as we previously stated through this presentation. The neutral's current carrying. And so most inspectors go along with this concept. If it's 51% or higher, then they're saying, okay, the neutral's current carrying. As an example, L1, L2, L3, 100 amp neutral load. If 51 amps or more is harmonically or non-linear loaded type neutral, then it's considered current carrying. The 50% rule, now you can get a better handle on that in 400.4A as in Apple. Now moving on down, we would size the grounded conductor now to serve as a path for an effective ground fault path from Table 250.102C1 based upon the ungrounded conductors. The ungrounded conductors at the service, as you see, is 230.42A1, 125% of the continuous load plus 100% of the non-continuous load or with demand factors. But notice continuous load, as you know, 3 hours or more, non-continuous, less than 3 hours, and then loads with demand. We find that in Article 100, definition of continuous duty or continuous operation. And then 230.90A, and exceptions 1 through 5 mainly, cover sizing the overcurrent device in the panel board that you see there in that case. And then the main bonding jumper, as you see in the grounding loop, is 250.28D as in dog, A as in apple, and B. And again, we're referred to table 250.102C1 to size the main bonding jumper. The supply side bonding jumper in any manner used is sized in accordance with 250.102C1, 250.90B, and table 250.102C1. Now, this grounding loop is very good because you cover everything that you need to know about that grounded conductor coming into the panel board that you see. The system bonding jumper, the main bonding jumper is all covered right there. The grounding electrode conductor in this case is covered by 250.66A because it's not connecting to structural steel or a metal water pipe in accordance with table 250.66. So illustration 16-69 is just basically illustrating rod, pipe, and plate electrodes that are used in accordance with 250.52A5 and A7, but they're installed by 250.53.